Hello, meteorology students. It's Mr. Johnson. Taking just a minute to give you some notes, classroom notes on layers of the atmosphere. There will be an Ed puzzle to watch following this to review the layers of the atmosphere again, and an assignment to be expected tomorrow. So with that, let's get to things. It's a great idea to actually take notes either on paper or on your Chromebook, as they will be helpful for later tests and quizzes. So let's get to it. First, let's name those layers, starting closest to the Earth and going furthest away. To begin with, our first and closest layer is the troposphere. Above the troposphere, we have the stratosphere, the mesosphere, and the thermosphere. So these are the four most widely recognized layers of the atmosphere. In this class, we are going to recognize also the exosphere, and we'll discuss a little bit later about why that's not always counted. If we look at a diagram here, we can see those layers in order. So we have the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So let's dive in and talk a little bit about each. The lowest layer of our atmosphere that is closest to the Earth is the troposphere, and it's within this layer of the atmosphere that we will be focusing the majority of our attention for the rest of this semester. And the reason that we'll be doing that is the troposphere is where the most of the weather, really almost all of the weather changes take place. In fact, tropos means to change. And this is where we get cloud formation. This is where we get precipitation, our daily temperature changes. Again, all of those changes happen in that troposphere. It can vary in terms of thickness, and in general, the atmosphere tends to be thinner around the poles and thicker closer to the equator. The majority of the mass of our atmosphere occurs in the troposphere as well, and that includes water vapor and CO2. Both water vapor and CO2, I will remind you from the last video, are variable. In other words, they can change. And it is that change itself that we're looking at when we talk about weather, because change in water vapor, change in CO2, well, that can be a big driving force in what happens to the daily weather. As far as temperature goes, the troposphere is characterized by a decrease in temperature as you get further up into the troposphere. We'll use a couple different words that essentially mean kind of the same thing in terms of how far into the troposphere you are. Altitude usually is used when you talk about distance away from Earth, and elevation typically is used to mean the distance away from sea level. But we'll kind of just use those somewhat interchangeably, essentially saying the further up into the troposphere we get, the colder it gets. Kind of an interesting thing about this is if you've ever hiked up in the mountains, the further up you get in elevation, the higher up in the troposphere you get, the colder it gets. So it can be, nice and warm in lower elevations, but as I've hiked up higher into the mountains, anytime I hike into the mountains high up, I bring a jacket because I know that I'm going to see a lot colder temperature. And I've always been thankful that I've had a layer of warmth. And what tends to happen is the temperature stops decreasing at what's called the tropopause. The tropopause is sort of the layer between the troposphere and the next layer above. And the tropopause actually is responsible for some of the sort of weather patterns that we'll get to in the next week, in the next couple weeks. There's a video that I'm going to skip here. I'm going to try anyway. Sorry. And we'll move on to the next. Again, like I said, the tropopause is the layer between the troposphere and the layer above it, which is the stratosphere. And this is sort of a cold trap. We have warm rising water vapor. So we have this warm air that has more water vapor in it, and that water vapor turns to ice. And what ends up happening is that ice then usually collects with other ice and becomes heavier, and usually it falls or stays closer to the Earth without falling or without escaping. Now, without this layer of being really cold, it would then move up into the next layer and just escape Earth. And so we can thank the tropopause for keeping water here on Earth. The layer above the troposphere is the stratosphere. The stratosphere, being really close to the tropopause, the very bottom of the stratosphere is cold. It's really cold. And as we work our way up through the stratosphere, temperature does something a little different. And it has to do with a molecule called ozone. Ozone is O3. What ozone does, most of the layers of the atmosphere, light can work its way through those layers of the atmosphere. Ozone is was one of the exceptions of the atmosphere actually being able to absorb certain wavelengths of light. And the ozone, this ozone layer, it absorbs UV light. And as it absorbs UV light, that ozone heats up, just like the Earth would heat up if it absorbs other wavelengths of light. Well, that ozone layer, not only does it absorb that UV light, like I said, that UV radiation, but that actually causes the ozone to heat up. And so as you get higher into the atmosphere, further away from the tropopause, you actually tend to get warmer as you climb higher away from Earth in the stratosphere. And at the very top of the stratosphere is the stratopause. And this has a very, very high temperature, again, because of the amount of absorption and the distance away from the troposphere. Skip that video for you. So the ozone layer, as we can see here, a lot of light can work its way through the atmosphere, but UV light tends to get absorbed by that ozone layer. Now, an interesting and unfortunate thing has happened where we as humans have made this funky molecule that we call CFC. The CFC, also known as chlorofluorocarbon, there's the big, long, fancy word. Basically, what humans use them for is to cool down our refrigerators for a very long time. And another thing that it was used for is to propel things, like it would be a propellant in things like hairspray and spray paint. The unfortunate thing is CFCs tend to go up and destroy the ozone layer. Now, if we're just looking at temperature and saying, okay, ozone is responsible for the stratosphere being warm, that's no big deal, whatever, who cares? Well, aside from throwing off the balance of one of our Earth systems, our atmosphere, it also has a direct effect on humans because ozone blocks UV light. And if you've heard of UV before, you've probably heard of it in terms of a damaging wavelength of light that can give you sunburns and skin cancer and eye problems and destroy crops and all sorts of things. Well, that ozone layer is really important to us. Unfortunately, like I said, CFCs tend to mess that up. The sun will hit the CFC, break off a little bit of a chlorine, and long story short, that chlorine steals oxygen away from O3, making it O2, which we can breathe. It's really far away from us, so we can't actually breathe, that product of this. But the point being is that O2 molecule is no longer going to absorb wavelengths of light. And so we are, in essence, thinning that ozone layer. Here's an image of how that works. You can see that chlorine goes and steals it. Now it's no longer O3, it's O2. So the nice thing is we as humans decided to more or less stop the production and use of CFCs. And so this problem of the ozone is sort of becoming a little bit better over time. Let's move our way up to the mesosphere. The mesosphere is a layer where it actually decreases in temperature as you get further away from Earth. It has very little solar radiation absorbed there. It tends to be the coldest part of our atmosphere. And at the top, it actually starts to increase again because the concentrations of gases change sort of with each layer. The mesosphere is also where we see meteors burn up. So if you've ever seen a shooting star, you have seen space debris get burned up in the mesosphere. You actually have not seen a star at all. You've seen, again, space debris burning up as it tries to fly its way through the mesosphere. The layer above the mesosphere is the thermosphere. Now, in the thermosphere, it steadily increases. By it, I mean the temperature steadily increases with altitude, and that has to do with N2 and O2 atoms absorbing that solar energy. In the thermosphere, the air is very thin, but special instruments have been used to measure the temperature, and it's extremely hot. This is where some of the space shuttles will orbit. And the thermosphere is also where we have what's called the ionosphere. So the two spheres sort of exist in the same area, in the same general location. Now, the ionosphere is made up of these charged particles. And what happens is solar radiation from the sun, obviously, make its way here, and they tend to excite these charged particles. And the gases will lose electrons, and essentially heat up, or not heat up. They'll illuminate. They'll glow, and this is where we get the aurora borealis, also known as the northern lights. And the reason that we tend to see the northern lights around the poles is because that is where the layer of the atmosphere. That's where the atmosphere is the thinnest, and so it's closer to Earth, and the solar energy is able to make its way into the ionosphere easier. Outside of that, the outermost layer of our atmosphere is the exosphere. The exosphere is not always included in the layers of the atmosphere because it's sort of that transitional space between our atmosphere and outer space. And so do you call it space or do you call it our atmosphere? For the sake of our conversation, we'll include it. Now, it's far enough away from Earth where Earth's gravity isn't holding on to the particles well enough to stop them from actually being able to escape into space. And that's why we have it sort of being a blended area. This is the region where our satellites orbit, and it's nice because there's enough gravity to keep things orbiting the Earth, but there's low enough number of molecules that the friction is very low, and essentially it's able to really easily orbit the Earth here. And like I said, it extends pretty much up into outer space. This is where I'll leave our class notes for the day. Don't forget to check Google Classroom for an Edpuzzle.